these are given. I multiply, I get this value, square it, I get this, and add them up. So I'm going to just plug in the number here. That is summation of x squared is 64.06 minus x squared 14 and then square it 1, 2, 3, 4. So I get 15.06. That is summation of the squares. Summation of x is 14 and square it divided by 4. I'm just plug in them. Next one is the summation of xy is 117.55 minus summation of x was 14. Summation of y was 28.4 divided by 4. That gives me 18.15. So V is then 18.15 divided by 15.06 is 1.2052. A is then Y average is 28.4 divided by 4 minus B is given as 1.2052. X over average is 14 divided by 4. And the answer I'm getting is 2.8818. That's it. So I have A and B. So the answer is 2.8818 minus B is 1.2052. That's times X. That's it. That's the answer. We want to have a straight line out of that. I'm not quite sure we will have this kind of problem, but if we do, we know how to handle it. Just grab this 5 expression, and in the table, we make a separate table like this, and just plug in. As simple as that. That is a kind of a problem. Statics, we should know what the mean is. Summation over x divided by n. Variance is the summation of x minus u squared over n. And standard deviation is the square root of x squared. are at the time. Like this. Probability of N1 is one kind, N2 is one kind, and so forth. We get that. For the combination, we can write this way, or N factorial, N minus R factorial, the combination. We talked about the probability of getting event A is n way out of n. Probability that is not going to be there is x minus probability of is going to be probability of A or B is probability of A times probability of B, both mutually exclusive events. Probability A or B is probability of A times probability of B minus probability of A and B. Probability of A and B is probability of A plus, I will take it back, I'm sorry. This will be plus, that'll be plus minus times probability of a B for the mutually exclusive event. Probability A and B is probability of A, probability of B slash A, something like this. First, we talked about uniform distribution. Uniform distribution. Next one is a binomial distribution. Next one is a normal distribution or Gaussian distribution. So here, x a and the b is 1 over b minus a. Here, binomial distribution. And here we have to use a z factor. Z is x minus mu divided by sigma. We have to convert that number to and mu is not that. There is a such thing as a chi-square distribution, but that's not talked about. Then what we talked about is the t distribution. And the confidence interval. Something like this, again. Then we just talked about the least square. Estimate. And there were 5 equations, remember.
So what is the last one? What is? What?
Three pages.
Thank you.
standard deviation, we have X, we have 1, 4, and 7. We want to get the standard deviation. And to get that, we have to have that, and this one is, so, to do that, first we have to get the mean. Mean is, this one is a 12. 12 over 3, which is a 4. So next will be this times the mean. 1 minus 4 is minus 3. 4 minus 0 will be 3. Next one is the x minus mean over square. 9, 0, 9. Add them up will be 18. So, will be 18 divided by 3 is a 6. So square root over 6. That's the answer. So C is that. Very straightforward. One board contains 8 white, 2 red, and another one board contains 4 yellow and 6 black board. What's the probability of getting a red from the first one and the yellow from the second? That's the question. Again, what's gonna happen here is not going to influence the other. So we can say this is a mutually exclusive independent event. The question was getting and the yellow. Formula said A and B is probability of A times probability of B, or mutually exclusive event, independent event. That's what the formula said. So the question was, what is the probability is going to be the red in the first one? And what is the probability of getting yellow one from the second? Getting a red from first board is a 2 out of 10. Getting a yellow one is a 4 out of 10 or so. The answer is 0.08. So I say, C is correct. Two independent events. So I'll be using that formula. Two independent events. So I use that. And 3 when x is less than 2 and greater than 1. The probability density function for x is equal to less than 1 and greater than 0 is. So it comes from the chapter of the variability. The formula said probability of x less than b and greater than a is integration of that. That's what formula is saying. So question was, what is the probability that x is going to be less than 1 and greater than is? To be integration of f over x dx, where integration is going to be x squared over 3 dx coming from 0 to 1. Integration of that is what? X cubed over 9 from 0 to 1, so it'll be 1 over 9. I say A is the correct. I'm just using that coming from the random variables. So the question was, what is from 0 to 1? So limit is 0 to 1. This is a given, so integrate that and get x cubed over 3 times 3 makes a 9, and so answer is 1 over 9. Number 4. 60% of a solar installation. The utility here is reduced by 1/3. The probably the utility here will be reduced by 1/3 in 4. X is a 4. Out of our 5 installation is. So 60% business is like a P. P is a 60%. So is the formula is a binomial distribution. This is what the formula for the binomial distribution says. So using this, x is a 4. N is a 5, P is a 60%, if N is a 5, is 4, success is a 60%, X is a 4th power, Q is a 1 minus P, so it'll be 40%, 1 minus success, N is a 5, minus 4 power. And they will do it. They will just clean up this one as the answer. Remember that when we have n x n over r like this, formula said it will be n factorial, r factorial, n minus r factorial. This is So to clean up that, I'd say 5, 4, this is equal to 5 factorial, 4 factorial, and 1 factorial, and I'm getting to be 5. Five times 4 factorial, 4 factorial, 1 factorial, this one drops out, the answer is a 5. So you can see 5 times 0.6 over 4 power and 0.4 over 1 power. So answer I'm getting is 0.259. I say B is the correct one. So use of a binomial distribution. Length of a telephone cord is normally distributed. The mean is 8 minutes. Standard deviation is 2.5 minutes. The probability cord will last more than 15.5 minutes is, so 15.5 more than. So we are talking about this area. The probability that the core will last more than what 15.5 minutes is, more than. So we are talking about right side of that. Since this is not equal to 0, we have to convert that with the z. It's x minus mu over sigma. So 15.5, mean is 8, standard deviation is 2.5. So I'm getting that to be a 3. So instead of a 15.5, let's use number 3. So this is one-sided. X is equal to 3. One-sided, the answer I'm getting is 0.0013. So let's look at the unit. So answer will be 8. Good EIT problem. But we should know how to